Hello everyone and welcome back to my channel. In today's session, we will look at 15 scenario-based interview questions that you can expect as part of your interview questions, and this will help you to master Kubernetes and also impress your interviewers. From deployment strategies to disaster recovery, I've got everything covered. Once again, before I start off with the session, please don't forget to hit that subscribe button. So let's jump right into it. The first question that I have is, you have a microservices based application consisting of multiple containers. How would you deploy and manage this application in Kubernetes? So for this, essentially what we can do is we can create a deployment object which is basically a microservice for each of the component that we have, for each of the component of the application. So within these deployment object, we will be specifying various information like which container image to use, what port numbers to use, any resource request or limitations on the resource utilizations, and also any environment variables or configuration settings. So we will be defining all of these details within the deployment object. Then we will need to create the respective services. So deployments will create the pods for us, but then if you want to access the containers, the application running inside these pods, we will need to create the services for them. So the Kubernetes services will help us to expose the microservices to other components within the cluster or external users. That is, the services will allow us to access or basically work with the application that we are running within these microservices. So that's how we can deploy the application. The next question we have is, your team needs to update the version of an application running in Kubernetes without causing any downtime. How would you perform a rolling update? So for this, again, we will make use of your Kubernetes deployments. And this Kubernetes deployments will mainly help us to manage the application's lifecycle and also perform rolling updates. So whenever we talk about performing rolling updates, we can make use of your deployments in Kubernetes. So how we will be doing this? So we will gradually increase the number of replicas with the new version of the application. So we will increase the number of pods, and these pods will be running the newer version of the application, and simultaneously we will decrease the replicas with the older version of the application that we are running, and this will ensure we have a smooth transition without impacting the availability of the application. So basically we will create a deployment which will where we'll be increasing the number of replicas of your pods, pointing to the newer version of the application. Simultaneously, we will be decreasing the replicas, which is pointing to the older version of the application. That way, we are smoothly transitioning to the newer version of the application without any impact on the availability of the application. The next question we have is, your application experiences varying levels of traffic throughout the day. How would you implement auto-scaling to handle increased demand automatically? So in Kubernetes, when we talk about auto scaling, we have this feature called horizontal pod auto scaling, or HPA, that your Kubernetes provides. Now we can use this to specify your target resource utilization metrics as to, when do you want to increase, or when do you want to auto scale your resources. We can define that. So it could be your CPU utilization, it could be your memory utilization. So basically, what is your scaling behavior? What is the behavior on which the scaling needs to happen? We can define that. So using these metrics, Kubernetes will automatically adjust the number of pod replicas that are running based on the real-time metric. So if my CPU utilization is at 80%, increase the number of pods. So based on the real-time utilization, Kubernetes will increase the number of replicas to meet the defined criteria. So, when it reaches 80%, how many pods do you want? You can define that criteria, and then your HPA will accordingly meet that criteria for us. The next question we have is, your tasked with deploying a stateful application that requires persistent storage. How would you ensure data persistence and high availability in Kubernetes? So we can essentially, for this, we can make use of your stateful sets to manage the deployment of your stateful applications. That way we can ensure that each of the pod has a stable network identity and also persistent storage volume. So again, here we make use of your deployments to create our pods. So deployments can be used for making your application, or rather making your pods having the persistent storage volumes and also having a stable network identity. So with this, we make use of your persistent volume claims, which will allow the pods to make use of the persistent storage volumes, and then also associating them with the storage classes that are available. Kubernetes will handle the storage provisioning and also management of this storage transparently. So uh, creating the storage volumes, the persistent volumes, and then claiming those persistent volumes. All those things can be done, and that way we can make your data is persistent, and your application is also having the necessary storage capacity that it needs. The next question we have is, how does Kubernetes handle service discovery and load balancing for applications running in the cluster? So, Kubernetes services is basically what we use to expose the pods to within the cluster or outside the cluster. So, basically, whenever, if let's say you're running a web application and if you want to access that web application, we make use of your services, which will expose those pods to access the web application. So, these services, this provides us with a stable virtual IP address and a DNS name, which can be used to access the pods running within the cluster. So we will have the application running inside a pod, and this pod will be behind a service. So as a user, we will hit this service, and the service in turn will hit the pod and get the response back from the pod. So services, it makes use of the kube proxy to essentially do the load balancing across multiple pod replicas and also distributing the requests evenly across the pods, and this will ensure we have a high availability and also we have a better fault tolerance in terms of the application. The next question we have is, you need to ensure that containers running in Kubernetes are securely configured and isolated. How would you implement container security best practices? So for this, we can follow various best practices in terms of your container security, such as using very minimal and only trusted base images. So, having proper, I would say, official base images, then implementing least privilege principles, enabling pod security policies, and then also regularly scanning the images, the container images, for any vulnerabilities. And we can do this by making use of your tools like Claire or Trivi, which helps us to basically scan the images for any vulnerability. So these are some of the best practices that we can use to make sure that we have proper images and we don't have any security breaches in terms of the application that we are running inside the container. The next question we have is, your organization wants to host multiple application with varying security and resource requirements in the same Kubernetes cluster. How would you implement multi-tenancy? So for this, we can make use of Kubernetes namespaces, which will help us to logically partition the cluster. So we know that namespaces are used whenever you want to create a logical partition within the same cluster. Like if you're running multiple applications within the same cluster, and if you want to isolate them, we can make use of your namespaces for them. We can also enforce resource quotas, and we can apply network policies, and this will help us to isolate and also secure the resources for each of your tenant or each of the applications that we are running within the respective namespaces. We can also implement RBAC, which is your role-based access control, that can be used to restrict the access and also control the permissions based on the role of the user and also the responsibility of the users. So we can make use of all these things to basically implement a multi-tenancy application within the same cluster. The next question we have is, your team wants to gradually roll out a new version of an application to a subset of users for testing before fully deploying it. How would you implement a canary deployment in Kubernetes? So for this, we can create a Kubernetes deployment but we'll have two separate versions of the application. So basically we will create two deployments, one pointing to let's say an older version of the application, and the other deployment pointing to a newer version of the application. And then we can make use of your service mesh like Istio or Linkerd to basically control the routing of certain portion of the traffic to the new version of the application based on the rules that we can define. And then we can also start monitoring and start looking at the metrics that can be used to evaluate how the newer version of the application is performing before we start promoting it to the full production or to the full users of the application. So essentially, we'll have two deployments. Let's say deployment 1 and deployment 2. Deployment 1 will be the newer version, deployment 2 will be the older version. And then we'll have service mesh like Istio, let's say, which will where we'll define rules as to how much, what percentage of the traffic should go to deployment 1 and how much should go to deployment 2. And then we start monitoring the newer version of the application. And then we start doing the evaluation, basically the performance, how the performance is. And if we feel that the performance is good, then we start promoting all the traffic to the deployment 1, which is a newer version of the application. The next question we have is, in the event of a cluster failure or outage, how would you ensure timely recovery and minimal data loss for applications running in Kubernetes? So for this, we can make use of your disaster recovery strategies. Now, there are multiple strategies when we talk about your disaster recovery. So some of the common strategies would be regularly taking backups of the cluster data and also the application data. And again, we have tools available for this. So we have tools like Velero or native Kubernetes mechanisms like taking a snapshot of the etcd itself, which is your cluster data. That way, if something goes wrong, we can recover the data from these snapshots. Additionally, we can also design a multi-zone or multi-region architecture for your Kubernetes, which will ensure we have a high availability and fault tolerance in case of something going wrong. So let's say if you're having a multi-region architecture, if there's an issue in one region, we still have another region where the application is running, and we will not have much impact to the users, or rather we'll have zero impacts. And even if something goes wrong, we'll be making sure we have proper backups, we can do a restoration of the application. The next question we have is, your organization wants to prevent resource contention and ensure fair resource allocation across different teams or projects in the Kubernetes cluster. How would you implement resource quotas and limits? So for this, we can make use of your resource quotas, which can be used to basically put a limitation on your resource utilization. So we can enforce limits on your CPU utilization, your memory utilization, and your storage utilization within the Kubernetes namespaces. So like for example, let's say you have a default namespace. Now within the default namespace, what is a CPU limitation? All those limitations can be put by making use of your resource quotas. Now by specifying maximum resource quotas for each namespace, we can basically prevent individual workloads from monopolizing the resources within the cluster. So we can make sure that the workloads are not taking all the resources, like single workloads are not taking all the resources. We can avoid that by allocating maximum resources to each namespace, and this will ensure we have equitable resource distribution across all the resources we are running within the cluster. The next question we have is, your team needs visibility into the performance and health of applications running in Kubernetes. How would you implement application observability? So again, with this, we can make use of Kubernetes native tools like Prometheus, which can be used as your data source. And we can make use of your Grafana for visualizing that data. We can also make use of Kubernetes events and logs for any troubleshooting. Additionally, we can also have applications with distributed tracing using tools like we have Jaeger or Zipkin, which can be used to have a distributed tracing across the applications. And we can use this for end-to-end visibility into the request flow. So how the request is coming in, how the request is going out, all that end-to-end visibility we can have, so that we have a proper monitoring in place, so that something goes wrong, or if you want to keep track of all the events that are happening, we can make use of all these things. The next question we have is, your organization follows the immutable infrastructure paradigm and wants to ensure that all changes to application deployments are versioned and reproducible. How would you implement immutable infrastructure in Kubernetes? So for this, we can make use of your declarative Kubernetes manifest, which is basically having all the instructions in terms of YAML file. So it could be your deployments, it could be your pods, it could be your services. Everything should be in a YAML file to basically define the infrastructure configurations and also your application deployment. So everything should be in YAML file, should be converted to YAML files, and then we can start storing these manifests in your version control systems like Git, and implementing your CI/CD pipelines, which can help us to automate the deployment workflows. This way we can ensure that all the changes are being tracked, all the changes are being tested, and also auditable. So that way, even if something goes wrong, since we are writing code, it is easily reproducible. We can go back to the same version of the application by simply rerunning the same version of the code. The next question we have is, your organization operates in multiple geographic regions and wants to deploy applications closer to end users for reduced latency and improved performance. How would you implement geo-distributed deployments in Kubernetes? So for this, we can leverage Kubernetes Federation or multi-cluster management solutions. So we have solutions like Anthos or Rancher, which can be used to deploy and manage your applications across multiple clusters which are running in different regions. Okay, so we can make use of these tools. We can also make use of your network policies and global load balancing. That way we can route the traffic to the nearest cluster based on the user location for optimal performance. So that's how we can do it. So basically the point is to deploy the clusters across multiple regions and implement global load balancing, so that the load balancer will route the traffic to the nearest cluster based on the location of the users. The next question we have is, your organization has workloads running on premises and in public cloud environments and wants to adopt Kubernetes for workload portability. How would you implement hybrid cloud deployments with Kubernetes? So for this, we can make use of your Kubernetes distributions that supports hybrid cloud deployments, such as using Amazon EKS Anywhere or Azure Arc or VMware Tanzu. So we can make use of any of these things that supports your hybrid cloud deployment. So when we talk about your on-premises and cloud, that becomes your hybrid architecture. We can also leverage consistent Kubernetes APIs and management interfaces across the on-premises and cloud environments. That way we can deploy and manage the workloads seamlessly across the hybrid infrastructure. So for this, we can make use of some of the tools, some of the services that are available to basically deploy our workloads across the hybrid infrastructure that we have. The next question we have is, your organization operates in a regulated industry and needs to ensure compliance with security and privacy regulations for applications running in Kubernetes. How would you implement compliance and governance? So for this, we can make use of your Kubernetes native security controls, such as your pod security policies, network policies, and RBAC, which is your role-based access control, to enforce any regulatory requirements and security policy. So we can basically put controls, we can implement policies which will help us to have the regulatory requirements accordingly. Additionally, we can also make use of your auditing and logging solutions to keep a track and monitor the activities that are happening in the cluster for any compliance purposes. So keep logging enabled, keep your auditing enabled, so that we have all the historical data and keep track of everything that is happening in the cluster. And that brings us to the end of your 15 scenario based interview questions that you can expect in your Kubernetes interview. Now, these questions will help you to ace your interviews and also demonstrate your practical Kubernetes skills. If you found this video helpful, please don't forget to subscribe to the channel. Please leave a like and hit that bell icon for more content. Let me know in the comments section what other topics you would like me to cover. Thank you for watching, and I will see you in the next video.